Hi, this is Professor John Barroso, and today we're going to look at factoring four terms. Okay, so when we have four terms, there are certain tricks that you need to know before trying to solve them. Also, if you have a factoring problem, you can email me and I'll be happy to make a video solution for you. At the end of this video, you will see 3 homework problems with solutions which you can work on to see if you get the right solution. Okay, we're only factoring simplest instances and simple instances when we can easily factor the pairs. We have 4 pieces, we pair them 2, 2, and we want to work on examples that we can easily factor each of the two terms. Okay, I mentioned here an example which is not the simplest one, and that's because if we pair here, we are not going to easily factor the 2 and the 3 and then the 4 and the 3. So we're not going to work on examples that require too much thinking, but if you're interested in seeing the solution to this one, here's the solution. The factoring after all is done is going to turn out to be 2x minus 1 in parentheses and then another parenthesis, and then here we get x squared minus half x plus 3 halves. Okay, but we are not going to work on complex cases like this. So let's see what we need to know before we start. Just a quick review here. And there are 4 types of factoring that you need to know before you attempt to work on a 4-term factoring. Okay, so I listed them here, and these are the case of a cubed plus b cubed. Okay, if you have this case, this is the solution. If you have a cubed minus b cubed, this is the solution. You can see that what we have here is actually the a plus the b term, and then the same sign that appears on the original problem repeats here and gets flipped here. So a plus will give you a plus and a minus. In this case, a minus will give you a minus and a plus. Okay, but it's not about memorizing. You really need to know these things, and you really need to understand why this is the case. So I assume you can go back and review your factory materials. Here, a squared minus b squared, the solution is a plus b, a minus b. Okay, you also need to understand why this is so, but this is it. Okay, and if we have in parentheses a minus b, we're going to get a squared minus 2ab plus b squared. You see that you get that because you FOIL it. Okay, there is a closing the parentheses here. So if you FOIL this, you get that. But what is really a minus b quantity squared? Well, it's simply a minus b times a minus b, because it's a minus b twice and multiply. Okay, so if you remember this and really understand it, you'll be okay when you learn factoring 4 terms. So let's look at the first case, which is on the screen here. This is a case where we have powers of 3, powers of 2, powers of 1, and powers of 0. Well, that doesn't mean much, because the complex example I showed you also has power of 3, 2, 1, and 0. So what makes this example easy is because the pairs are pairable, and I put in parentheses here because I'm under the impression I just made up a word here. But the pairs have to be pairable in order for you to solve this. And what I mean by that is that once you pair them, you can easily factor. So what catches your eye here should be the fact that we have x cubed plus x squared. So this pair is already in the right order, And these two guys here are also in the right order. So if I try to factor this first pair, I can pull out x squared because that's the most that they can give me. Now if I pull out x squared, I get an x here, and x squared times x is going to give me x cubed, okay, because this is x squared plus 1, which the 1 comes from this x here, and this gives me the x cubed, which is the value I had when I started off. Now I don't need to show that power of 1, so I'm going to take it away. There's no need to show that. Plus, note that the x squared, the whole x squared went out, so now I have a number 1 here. It's not a 0, okay, because x squared times that 1 gives me the value I had before, which is x squared. Now, what do I do with the second pair? Well, I see 2 and 2, so I put the sign I see there, I pull out the 2, and I get the x. Here, these two together give me 2x, and a plus sign. Now, that 2 went out, so I have a number 1 here, because 2 times 1 gives me the original value I had. So now we see that x plus 1 repeats, and what I need to do now for the solution is to take the x squared plus 2 as my first part, and then I take the part that repeat, which is x plus 1, and this is the solution. Okay, so this is the simplest case of 4 terms. Now let's move on to a slightly more complex case here. Let's see what's going on with this one. For this case here, we see x cubed, x squared, x squared, x cubed. So don't worry too much about order. What you need to consider here is that we have powers of 3 and powers of 2. So if you see that power 3, power of 2, we want to pair, okay? A main thing in 4 terms, okay, keep that in mind. 4 terms is always solved by pairing, okay? So you're going to create pairs. So the pairs, which two would you put together? Well, it appears that it's natural to consider the powers of 3 together and the powers of 2 together. So 27x cubed plus y cubed. And now we continue rewriting minus 9x squared plus the y squared. So here we just rewrote, and now we have the pairs. However, when I look at this first pair here, I see that they are power of 3. Well, let's go back to what I just told you that you need to know before you do this exercise. How to factor powers of 3. So let's see that our sign is a plus. So we have this very case, which I'm going to highlight now. We're talking about this very model here. Okay, so note that I need a number which I call A, and I need a number which I'm going to call B, and then I follow the model. Okay, so to find that number which I call A, I'm going to think of it this way. Here is A inside this parenthesis. If I cube A, I have to get 27x cubed. So what is the number or the expression that once cubed gives me 27x cubed? Well, 3 times 3, 9 times 3, 27. X times x times x is x cubed. So this guy here is what we are calling A. Alright, now let's look at this case here. I need a value here. When I cube it, I get y cubed. Well, that's pretty easy. It's y. So this guy here is what we are calling B. So now I know who A is and I know who B is. Let's go back to our model. Here's our model. Okay? I only have A's and B's all over. So I know who A is, I know who B is. I just plug it. Okay? So back here, let's write this model again so that we don't forget what the model is. The model is A cubed plus B cubed equals A plus B, close parentheses. Now we take A squared. Note, I have A plus B. The sign is going to flip. It's going to be a minus. Okay, minus what? AB. And then plus B squared. Okay, and this is the model. But I know that the guy I'm calling A is 3x. And the guy I'm calling B is y. So we're going to come back here and we're going to say that we have, for this piece here, I have 3x plus y. And for this piece here, I'm going to have 3x squared, that's 9x squared, minus, well, the A times the B, so it's 3x times y, it's minus 3xy, 3xy. And then the B squared, so it's plus y squared. Note, we are done taking care of this first cubic part, but now we have to turn our attention to the second term. The second term is 9x squared negative plus y squared. Note that here, for this case, we have a number that when I square, I get 9x squared. So who is inside the parentheses? Well, 3 squared is 9 and x squared is x squared. So our A guy here is this 3x. Now, who is the B guy? Well, the B guy is pretty simple. It's somebody, when I square it, I get y squared. So who is here? It's y. So this is our B guy, and it's y. Let's go back, look at our model. And note that we have a plus sign in between. Okay? So, well, I kind of skipped that part, so I have to rewrite this minus 9x squared plus y, and I'll show you what's going on here. We have minus 9x squared plus y squared. I'm going to take this minus outside, okay, so that I get 9x squared inside. But now, to maintain my positive sign, which is the original sign, I have to put a minus here, because then this minus and that minus together will give me the original plus. So we're getting minus y squared. All right? So now that I rewrote this by moving the minus to the outside, we go back to look at our models. And here we are. We have that a squared minus b squared is simply a plus b, a minus b. Okay? So we'll go back there, and we're going to say that this second piece is a plus b, a minus b. Now, who is a? Well, a, let me get to highlight here, a is 3x, and the b part is y. Okay? So I'm going to rewrite this piece here, but to organize it, I'm going to rewrite the whole thing. The piece we already found, 3x plus y, and 9x squared minus 3xy plus y squared. Okay, that I just copied it, and this guy here, it's the model is up here, a plus b, a minus b. So I'm going to rewrite this as a plus b, a minus b. Our a is 3x and the b is y. So this is minus a, I'm sorry, it's not a, it's our a is 3x and plus the y, and then 3x and minus the y. Okay, so this is done, but it's actually not looking quite good, because we have here, we can easily spot that we have 3x plus y and we have 3x plus y. So we want to improve this a little bit by factoring out the 3x plus y. So I'm going to pull out 3x plus y. Okay, there is nothing to pull out of this piece, so I'm just going to copy it, and because I'm pulling out, I can actually do that and rewrite now 9x squared minus 3xy plus y squared. Now note that I pull this whole 3x plus y, so in each place I have a number 1. So this is minus 1, but these two guys are multiplying, so it's minus 1 times 3x minus y. And now I close here. And this, even though it is correct, it's still not looking pretty. So let's make it look pretty. I'm going to put the final solution in red. This is going to turn out to be 3x plus y. I'm just copying. Okay. And now 9x squared minus 3xy plus y squared. Now note, this minus 1, I want to distribute the minus sign, so it's going to give me minus 3x. And I also want to distribute the minus sign here, so minus and minus, minus and minus is going to give plus. So this will be plus y. And now we close, and this is the final answer. It's factored. Let's move on to the next example. And in this example, we have 3 equal powers of 2. Okay, 3 equal powers of 2. And one term is power of 1. So if you look at this, you might be wondering, how can I pair? And you can't lose sight that 4 terms is always pairs. Okay, so your main thing is to find the pair. Okay, pairs. How can I pair this? Well, there is a hint here. Look at this guy, the guy that does not have power of 2. This guy is telling us, and I'll call it hint. Okay, it's telling us that we should really work on variables x and z. Oh, that's all. Yeah. So we're going to rewrite this way. Inside these parentheses, only x and z is allowed. Okay? Whoever is not x and z has to go out. Well, y has to go out, so minus y squared. Now let's complete the inside. Only x and z. So we have x squared. Now we want this guy first, okay, because it's the binomial expansion with the middle term that gets in there. And you saw this in your previous practice on factoring. Okay, so now we have minus 4xz and plus 4z squared. Okay, so now we rewrote it, and now we need a little thinking here. Well, but if you pay close attention, you're going to realize, hey, this is a perfect square. Hey, this is a perfect square. So let's take a look at our cheat sheet up here. All right, so let's see here. If I have a perfect square, it means that I can take, let me highlight it, I can take this case here, and I can simply find who is A and who is B and use that model. That's all. Okay, so who is A, who is B? Because I'm going to have A minus B squared. So let's go back there and see who is A, who is B. Alright, so A is somebody. When I square, I get x squared. So inside here is x. This is what we are calling A. Now, B is somebody. When I square, I get 4z squared. Who is that? Well, 2 squared is 4, and z squared, and z is squared is z squared. So this is my B. Okay? Now, let's rewrite that model again, and then we will plug the values. The model is this. It is A minus B, parentheses, squared. Okay? Now, what is really this? Well, it's 2 of this, and then we FOIL. Well, 2 of this is simply A minus B times A minus B. Okay? Now, you could FOIL this and get something like, I'm going to FOIL, but there's no need. A times A squared. A times minus B is minus AB. And then I have B minus B times A, it's minus AB again. And minus B times minus B is plus B squared. And from here, we're getting A squared. And this is minus 2AB plus B squared. But look, for our purpose solving this problem, we only need that. Okay? Now, we know who A is. A is X and B is 2Z. So let's plug these values in. So we have X minus 2Z squared equals. Now, this is just 2 of those. Okay? So it's simply what? X minus 2Z and X minus 2Z again. Oh, but what happened to the y squared? The minus y squared up here. Well, this minus y squared is simply minus y times y. Right? So here, I'm going to continue to call it minus y squared, but I have one negative, one positive. So all I need now is just to take one of each of these y's and give to each of the terms in parentheses. So the solution is going to be x minus 2z. Now I put the minus y in. Okay, I'll put the minus y in. Now I'm looking here now. I take x minus 2z, and this time I put the plus y in. And this is the solution. Okay, not hard, but if you don't see the trick at least once, it could be very hard. It could also be almost impossible. Okay, now let's see here. I gave you a little homework. This is the homework. They're similar to what you saw. Here are 3 problems, one of each type. Look at this, get a sheet of paper, solve by following all the rules, and see if you get this answer. This is the right answer. Okay, here's another example, solve and see if you got this answer, and look at this and see if you get this answer. Okay, so this is the end of the simplest instance of factoring for terms, polynomials. If you have any questions, email me. If you have a request, email me. I wish you good luck. Goodbye.